the z-score. Once you find the z-score, this is all you need to do is basically, again, locate your z-score on the table or in the table, right? The table that we've been using. And again, if your shaded region is to left, then the answer is in the table. Whatever the area in your table, in your chart, that's your answer. If they ask you if you shaded the region to the right, then all you need to do is take 1 minus the area that you have on the table. And if they ask you if you shade a region in between, then again, you just have to take the higher area minus the lower area, right? And again, the last item, number 4, is basically you have to interpret the area, interpret your answer, okay? Mostly on Alex, I think part 4, they ask you to choose which one is a correct correct item explaining your information. Okay, so let's take a look at this thing here, which is, again, let's take a look at the problem. This is your problem, ladies and gentlemen. So this is what they say is if a weight of oil in a package are normally distributed, and again, the only reason they put in the normally distributed plot is your data is a bell-shaped curve, right? Without that, we don't know what the data is. We don't know if it's skewed to the left, skewed to the right, scatter, or whatever. But anyway, normally distributed is good, which is a bell-shaped curve. The mean, the median, mode at one location, right? So with the mean of 518 grams and the standard deviation is 4 grams, find the following. They ask you find the percentage. Like I mentioned last time, the percentage, the probability, or the area is the same. They just changing the word on you guys. Don't freak out, okay? So again, find the percentage of the package that will weigh less than 510 grams. What does it mean? Less than, remember, less than is below meaning to the left of 510. Find the percent of data that will weigh more than 528 grams, and find the percentage of the data that will weigh between 514 and 520. So that's our question here. So again, let's attack one at a time. Let's attack A. Let's take a look at A by itself, right? So look at this thing here, which is if you go back to the step, if you have the slide, you go back to the step. The first thing you want to do is you want to sketch your normal distribution curve, right? And again, it doesn't have to be perfect. It's on the computer. If this were to be in a class, I do not draw this perfect. So again, once you identify, once you sketch your standard normal distribution, just identify your boundary, which is everybody see that my boundary is 510, which is now I'm looking for the weight less than 510, which is, do you agree that anything to the left of 510 is less than 510? Remember, the smaller number to the left and the bigger number to the right, right? So again, the smaller number, which is 509, 508, 5 whatever on the left side, right? So looking at this thing here, that's what they ask you to do, is identify which region do we looking for, which is, do you agree that we're looking for the region to the left of this item, which is to the left of this item, life is good. Why life is good? The answer is in your table. But the problem comes is you look at your table and you say, wait a minute, I don't see 510 in my table, because in your table, they only have a z-score. So that's the first thing we need to do now before we're looking at our table. The second step is we need to convert the data to become a standardized normal or standardized value, which is the z-score. And to do that, reminder, we take the data, which is the data is 510 minus the mean, which is the mean is 528, divided by the standard deviation, which is 4, which is the information is up there, right? From the problem to part A, those are the 3 numbers they give us, right? 510 is the data, 518 is the mean, and 4 is the standard deviation. And again, if you subtract this thing here, you have a -8 divided by 4, and -8 divided by 4 is -2. Now, what do we do? Again, instead of put the chart, I just extract out the -2, right? So this is your -2, ladies and gentlemen, your -2 z-score and the corresponding area. So is this my answer, 0.0228? Hopefully you guys say yes, because again, this is the area to the left, which is, again, the area to the left is the area in your table, which is, this is what we have, and this is the last item. how do we interpret? To interpret this thing here, we say that 2.28% of the oil package will have the weight less than 510. Okay, so again, why do I put in the percentage? Because the question they ask you in percentage, right? They ask you find the percentage of the package. So because they ask you in percentage, that's why we convert to the percent. We move the decimal 2 places. Okay. So again, just think in terms of this thing here. Let's say that each package of the oil, I don't know what the weight, but let's say each package of the oil, if they have 10 oil cookie in there, it will be 518 gram, right? Let's say that if there are 10 oil in that package, then the weight is 518 average, right? So if you buy a package and let's say this package have only 9 cookie in it, 9 oil cookie in it, it will weigh less, right? And again, basically, let's say that if it's 9 cookie, then it's weight 510. Now we want to know if you buy a package, what's all the chance that you buy a package that is way less than 510, which is you have less than 10 cookie in it, right? So again, that's the idea of this thing here, which is again, the idea is convert to the z-score so that you can use the distribution table. Okay, so let's try another one, which is again, let's take a look at B, which is again find the percentage of the data. Find the percentage of the data of the package that will weigh more than 228. So what does it mean, more than 228? More meaning again above, or anything to the right is more than 228. So the first thing we want to do is we want to identify, sketch your normal distribution curve, which is a bell-shaped curve, right? And then again, just identify. And again, this thing here is a lot off. I just wanted to show you that again, we found a boundary and then we shade in our boundary. Okay, so again, this thing here is not really that much. Okay, this thing here is very small down here. I just don't want to make it too small that you don't know. So I kind of make it large, but it's not a proportion to the problem, as you will see later. Okay, but again, first of all, everybody see that we sketched this thing here, and because we're looking for more than 528, we're looking for the item to the right of this thing here, to the right of 528. And again, to do this thing here, once we have this thing here, and again, like I say, the second step is we need to find the z-score corresponding to 528. And to find the z-score corresponding to 528, we have to take 528 minus the 518, divide that by 4, which is 10 divided by 4 to give you 2.5. Which is again 2.5. That's your z-score, ladies and gentlemen. That is what the number we have to go into our data, right? We have to go into our chart and extract out the 2.5, which is 2.5. Everybody see that 2.5, the corresponding area or the percentage is 0.9938. Which is this my answer? Hopefully you guys say no, because we are not looking for the item to the left. If we're looking for the item to the left, 0.9938, your answer. But because we're looking for the item to the right, reminder, what do we need to do? If we're looking for an item to the right, we need to take 1 minus the 0.9938 to give you 0.0062. And again, how do we interpret this thing here? We just say that 0.62%, not even 1%, ladies and gentlemen, not even 1% that the oil cookie package weigh more than 528, which is, it's very, very, if you